Let's do this. I'm going to give you some time at the end of class today to start that checkpoint, the 4.01. All right. Monday. Remember what you learned about ellipses. Think about what you already know. And then later today, we'll check in and see what did you learn today about ellipses. Here is a reminder for you. So remember, the vertices are on the longer axis and the covertices are on the shorter axis. They can go vertical. Yep. They can go either way. Yep. Oh, the foci. The foci are always inside the ellipse on the longer axis. So on the major axis. Good. Yep. They can go either way. Good. A is the distance from the center to each vertex. And then B is from center to co-vertex. And then C is center to focus. And then we have that formula. Also remember, yes, A is always the bigger one. A is always the bigger. Okay, so here is a quick warm up. See if you can pick out the equation of this ellipse while I open up Nearpod. And you can pick your answer on Nearpod. I'll get that code for you in just a second. All right, that is ready for you to submit your answer. So you should be able to find the center and then eliminate two choices based on the center. And then with the remaining two, you should be able to decide based on the direction that it's longer. All right, let's go ahead and go over it. We had several people pick B. And one person choose D. Okay, so the center looks like it is -3, 0. Remember, we can use those two axes and find where they intersect. All right, did you remember to take the opposite of H and K? So it would be a +3. So neither A nor C, which nobody picked. Okay, okay. All right, now, since it's longer up and down, Y is going to have the larger denominator. So it is D. It is D. The bigger denominator is underneath Y because it's longer up and down. Yep. All right, so for this one, the minority was right. Just one person. Okay, so it looks like for this one, yep, it's up and down 7 and left and right 4. Okay. Okay, so on Monday, we did examples 1 and 2. I think I don't know if we got to example 2. But it's pretty similar to the warm-up we just did. Do you guys remember? Did we do this one? The center was 0, 0. Anybody remember? Where'd you come from, Georgia? Really? Well, let's go back and look at that. When we graph it on Desmos, B matches? Are you sure? Can you share your link real quick? D is stretched vertically. Yeah, so is this one. This one's stretched vertically, I would say. Do you have your Desmos link, or do I need to type it in real quick? Okay. I thought I was going to sneeze. Okay, let me see. Securely starting on. Hold on. Okay, so the red one, the blue one. Yeah, that's it. Maybe there was a little mix up there. That's okay. No worries, no worries. Okay, then we were going to go back real fast to number 2. This one has a center of 0, 0. Next, we're going to look for A and B. And that's all we need to write the equation. The center and A and B. Remember, A is the larger. How far is it from the center to a vertex? Three, yep. Okay, so that's 3. And then B, left and right, 2. Yep. All right, so now the equation. X minus 0 is X. Y minus 0 is Y. So anytime it's centered at the origin, it'll look like this, X squared plus Y squared. Just like with circles. All right, just like the warm-up, this one's longer vertically, up and down. So A squared goes underneath Y. 3 squared is 9. 2 squared is 4. And you could check it in Desmos. What do you think? Does that seem pretty straightforward right there? I like ellipses. I know there's still a lot of details that we're working on, but sometimes it's pretty simple. A is always bigger. If it's longer up and down, A is going to go underneath Y. A squared goes underneath Y. If it's longer across, A squared goes under X. But A is always the bigger one. So A is either going to go here if it's longer across, or here if it's longer up and down. Yep. It retreats to the right. Yep. The 4 and the 9, you're just going to square these. So you don't actually put the 3 and the 2 in. You do a squared and b squared. So 3 squared is 9 and 2 squared is 4. Good questions. I'm so glad you're asking. All right, there is another one of these. Do you think you can do it real quick? Let's see. If I have it over here in Nearpod for you. You can go ahead and start it. Oh, no, it's not in Nearpod. Never mind. Oh. No. Oh. Oh no, I just did something on Nearpod. I don't know if it'll let you, if it's this one or not. You can check it out if you want. All right, so this is the simple type of problem. It's a blank screen. Okay. If you want to write your answer on there, you can, and then I would see it. If it lets you write on it. I agree. The center looks like it's at 0, 1. Okay. You can also share here in the chat. You find A or B. Yep, B is 3. Yes, yes. Good, good. It is the first equation because it's longer left and right. A squared under X, that's right. Coming together, guys. All right, I think we have it. Okay, so the center was 0, 1. And then A and B. Okay, so the center is pretty easy to plug in as long as you remember to take the opposite. I think that's it. So because it's longer left and right, 7 squared goes underneath the X. And then it was up and down 3, but you don't use 3, use 3 squared. So that goes under the Y. That's it. Doing good? Sounds like you are. Okay, yesterday we did not get into the foci, so we're going to do that today. And that was number 2. We're going to pick up right here with number 3. Write the equation of the ellipse, and then find the coordinates of the foci. All right, we're given the vertices and the co-vertices. This one's going to get a little bit messy. All right, 2 ways we could do this. We could do it algebraically without the graph, or we could do it geometrically with the graph. Graph tends to be a little easier. But we'll see. I'll kind of show you both. Okay, so if we start out with the graph, let's just plot the vertices. So we have 4, 8 and 4, -10. Okay, so we should be able to find the center from those, right? Halfway in between. So we could count how far and then take half. Okay, let's see, from -10 to 8 is 18, so half would be 9. So we can count up 9 or down 9. Right there is the center. Okay, from here, we're also going to be able to find A, right? Because A is from the center to the vertex. Okay, let's look at how we can find the center without the graph. So ignore the graph for a second. We could use the coordinates, and the center is halfway between them, right? Also known as the midpoint. Yep. And so to find the point in the middle, we just average the coordinates. Good. So for the x coordinates, what's the average of 4 and 4? 4. And then if you average 8 and -10, you just add them together, divide by 2. Average the y coordinates. So when you add those, you get -2, divide by 2, and that's -1. And so that is the same thing we got when we did it on the graph. Okay, so with or without the graph. Okay, A, so we can count from here to here on the graph, or without the graph, we can just look at the coordinates. How far is it from 4, -1 to 4, 8? Or how far is it from 4, -1 to 4, -10? So from -1 to -10 is 9. So A is 9. Okay, let's graph those co-vertices. Okay, and from here we can see it's an egg. It's longer up and down. All right, what is B? 5. So we could count 1, 2, 3, 4, 5, or we could compare over here from 4 to 9 is 5, and from 4 to -1 is 5. Good. Okay. So right now we can go ahead and write the equation. So let's do that. Plug in the opposite. Okay, always equal to 1. Don't forget that part. Without that, it's not an equation. Longer up and down. So a squared is underneath the y. So 9 squared is 81. 5 squared is 25. All right, any questions here before we do the next part? We're going to find the foci next. Okay, so we know those foci are going to be up and down because they're on the longer axis. So somewhere along here is where the foci will be. To find exactly how far they are from the center, we need to calculate C. And remember, there was a formula. A squared minus B squared. So that's 81 minus 25. Okay, so you see A and B. You don't put the 9 and the 5 into the equation, you got to square them. So 9 squared, 81. 5 squared, 25. If we go back and look at the equations that are on your formula sheet, notice those denominators is not just A and B. It's always going to be A squared, and the other one's going to be B squared. Good. Okay. So we're trying to figure out where the foci are going to be, to figure out exactly how far from the center. We calculate C from this formula. All right. When we subtract, that's 56. And right here, this is why it's a mess, because this is not a whole number. So it's going to get a little bit messy. Sometimes it is a whole number and then it's not as messy. So it is, it's approximately 7.5. Okay. And we're going to do both. We're going to give exact coordinates and we're also going to do exact coordinates. Nope, we're not going to keep it square root of 56 because you guys, we can simplify that radical. Let's do that over here on the side. The square root of 56. Oop. So 56 is 8 times 7. And then we can simplify 8 with a perfect square. That's what we need, is a perfect square. So that'll be 4 times 2. And then take the square root of 4. So this is 2 times the square root of 14. Okay, you could also do like a factor tree. You might have done that before. And look for pairs because pairs are squares. So there's a pair of 2, so you put a 2 on the outside, and then the 2 and the 7 stay at home, and that's the 14. Okay, 2 square root of 14 is the square root of 56. All right, let's look at where these would be on the graph. So we're going to go up and down about 7.5, 7.5. 7.5. So right in here is 1, and then down. And there's the other one. Okay, we are going to find those coordinates. Okay, so because we are going up and down from the center, okay, which the center is 4, -1. So because we're going up and down, the y coordinate is going to change. So the x coordinate is still 4. I'll restart it. Okay. So it's still, these foci are still to the right 4. So the x coordinate is 4, but the y coordinate is going to change when we go up and down. So we're going to go up 2 square root of 14. So take -1 right here at the center, and we're going to go up 2 square root of 14. So we add. And then we're going to go back to the center. So back to 4, -1. And we're going to go down 2 square root of 14. So we subtract. Okay. So those are the exact coordinates. -1 plus or minus 2 square root of 14. So sometimes you will see them like that. today on your assignment, you're going to see the decimal approximations. And for that, we just put these in the calculator. So what is -1 plus 2 square root of 14? About 6.5. Okay, that's this one right here. It's about 6.5. And the other one, we're going to subtract. So -1 minus 2 square root of 14. It's about -8.5. Okay. So it's a little bit messy with the radicals, with the decimals. But that's how you find the foci, is you find C from our formula and then go in the same direction as the vertices on the major axis. Okay, that was the messiest part of today. Okay, and once again, you could check it. If you graph it in Desmos, you could verify those vertices and co-vertices. All right, ready for the next one. Another one, we're going to write the equation of the ellipse. What, the messy ones? I call them messy ones. And then I refer to the other one that we did as like a simple one. This one isn't so bad. Oh, that's good. There was a lot of splatter. Okay, here we go. From the foci, we're going to be able to find the center because it's in the center of the foci. We're going to be able to find C. From the major axis, we can find A, and then we'll go from there. This time, I'm going to start without graph. So I'm going to find the center. Again, you can use the midpoint to do that. So we're going to add the x coordinates and divide by 2. Add the y coordinates, divide by 2. Go ahead and do that. What do we get for the center? And you can tell that, Georgia, because of the direction of the foci. Good. Mm-hmm. 1, -4. Okay. Next, what is A? So the length of the major axis is 26. That's from one end to the other end. So how far is it from the center to an end? So A is 13. The major axis is always 2 times A. If you double A to get the major axis. All right, what else? We could go ahead and find C. How far is it from 1, -4 to 6, -4? Or from 1, -4 to -4, -4? From 1 to 6 is 5. And from 1 to -4 is also 5. Yep. See, so you can do it carefully without a graph. Okay. Now for those that like the graph, those are the foci. See, so it is going to go left and right. The foci are on the longer axis. Then we can find the halfway point, AKA the midpoint. If we count this, it's going to be 10. So halfway is 5. So right there, it is the same, 1, -4. C. So if you count from here to there, it is 5. Okay. Now it doesn't say to graph, so we don't have to do the whole graph unless you want to, need to. So like right now, we wanted to go left and right 13, we could. But what are we doing? We're writing the equation. So we just need to find B. And for that, we can use the formula. And you say it's 12. So that would be what? That is 25. So it's a little triple, isn't it? So we get -144. And then we can divide by -1 or switch the sides. Make it positive. Okay. Yep, that's right. Happy, happy. C is center to foci, focus, singular. Yep. And now we're done. So let's write the equation. Okay. A squared is going to go, oh, Pythagoras. I just said that. Yep. A squared is going to go underneath the x because it's longer across. So A squared is 169. And B squared is 144. Yay. That wasn't too bad. So usually from the information they give you, you can either find A, B, or C. Like you can usually find 2 out of the 3 and then use the formula to find the third one. That is it. We are doing so good. Okay. One more thing about conic sections that we need to take a look at. And then we're going to start the assignment. Eccentricity. So kind of a sophisticated word there, but the eccentricity of a conic section is a ratio. And that ratio is C divided by A. It's ratio of C to A. And C, we know what that is. That's the distance to each focus, and A is the distance to each vertex. So we're looking at the ratio of those two. And so for all conic sections, the ratio is going to be the same. E is equal to C over A. So let's take a look at the eccentricity of an ellipse. So here you go. And I do have a little notice and wonder board on Nearpod. So see what you notice about the eccentricity, if anything. And then you can share what you notice in Nearpod on the board. Okay, at the top, there's a slider for E. So you can change the values of E and look at what happens to the ellipse. I think you can also change A, the vertices. Good. E is between 0 and 1. So X gets smaller as eccentricity gets closer to 0. And, excuse me, I said that backwards. X gets bigger as eccentricity approaches 0 and smaller as eccentricity approaches 1. Let me look at that. I don't know if I noticed that. So if I start here, X. I see. The X coordinates of the foci. That's a good one. So as E gets closer to 1, the foci get closer to the vertices. Or in other words, as E gets closer to 1, as E gets bigger, the foci are more spread out, right? And as E gets smaller, the foci get closer together until you get to 0. And then what happens when E is 0? This sounds like a Cody answer. Never mind, it sounds like a Georgia answer. When E equals 0, it's a circle. Okay, so we're gonna keep moving. Good job there, you guys. Oh, something else to notice is as eccentricity gets bigger, not only do the foci get further apart, but as eccentricity gets bigger, the ellipse is elongated. That's a fun word. So the ellipse gets longer when the eccentricity is bigger, and then when the eccentricity gets smaller, then it is more of a circle. Okay, so to fill this in real quick, you guys already said for an ellipse, this ratio is between 0 and 1. We also saw that for a circle, the ratio is equal to 0. The eccentricity equals 0. So E is between 0 and 1. Okay. This one, we're not going to do. We're just going to talk through real quick how we could do it. So of course, from the vertices, we can find the center, either going back. Yep, there we go. Sorry, I'm trying to rush so you have some time to start your assignment. So for an ellipse, it's between 0 and 1. And for a circle, eccentricity is 0. Okay. All right, so from the vertices, we can find the center, midpoint, or graph. Then from the eccentricity, we can determine A and C. Okay, so C is 3, A is 5. That's all we need. From there, we can use the formula to find B. And then finish it up. Okay, so we're not gonna do the whole thing, but you can kind of see how you could use that to find the center and C and A. Okay, so now we're gonna go ahead and open up the modules. We have about 6 minutes. You can go ahead and preview the assignment. It's 4 questions about ellipses. And you can have a second attempt on it. And let me know if you need anything. Sorry, you only have a few minutes here. No, it's due Tuesday. Since there's no school Monday, it's due Tuesday. All right, you guys, it is time for us to go. So keep working on that assignment. Tomorrow, if you finish your pretest early, then you could have some time in class to work on it and or get help. It's not due till Tuesday, along with the IXL from yesterday, also due Tuesday. Okay, I will see you guys tomorrow. Have a good afternoon. Bye, everyone. There is directrices. Uh-oh. Okay. Thank you, Cody. I will take a look at that. Thank you.